we have an overview of the joint type. So the adhesive joint, bell and spigot. The laminated joint, you just wrap material around the pipe. Possibly also you make a small internal laminate. We have the flange joint, of course, especially to connect fiberglass with metallic piping or with valves or nozzles. And we have the rubber seal lock joint, and again it's bell and spigot, and then you have a rubber seal, here it is yellow, to seal for pressure, same as that you have a seal in a gasket seal at the flange, the same way you have a seal here. And then the red one that you see here is the locking ring. So there's a groove in the bell and the spigot, and the red locking ring, it keeps the two together. So if there's tension on the pipe due to, for example, pressure thrust, the locking ring keeps it all together. And of course, if you make mistakes in the laminated joint or in the adhesive joint in the grinding or the mixing, then of course you can expect failures. Also, if the locking ring is not positioned correctly, if it's twisted, then you can expect a leak. Here we see an example of the bell and spigot joint that failed. But what is interesting here is that the surface, here you see yellow is the pipe surface, the surface of the spigot, and then black is the surface of the adhesive. And the surface of the adhesive looks very smooth, so it looks like there was little bonding between the bell and the adhesive. If there was good bonding, then you should still see some traces of glass that bonded, and should be more rupture of the fibers, maybe due to poor grinding or maybe due to curing that starts too early. But at least you can conclude from this photo that the joint was not of good quality due to installation errors. Here we see an example of a failure of a laminated joint. Possible causes are partly the same as for the adhesive joint, but also some different causes. So again, it is important for this type of joint that you do sufficient grinding. Also, you don't want contamination of grease or oil or water. But what is also something that you don't want with laminated joints is that you don't want dry spots. So people apply the glass layers by hand, and then other people apply the resin with rollers. They apply it the same way that you are painting the wall, for example. With the rollers, they add the resin. Yeah, if you miss a spot and you get a dry spot, of course, that's very bad for the quality of the joint. What can also happen is that the curing goes too fast. For example, this large joint type, it can be that to create the outer laminate, it may take a total time of maybe 45 minutes to do the winding. To create sufficient thickness, maybe you need to wind around the pipe 30 times or 40 times. That can take, for example, 45 minutes. If the curing of the resin starts, and the resin, it also depends on the type of resin, polyester or vinyl ester, but when it starts curing, then it generates heat and it accelerates the curing of the other layers, of the more outer layers also. So when at the outer layers of the joint, it is curing while you're still winding more glass material, while you're still manufacturing the joint at site, then the cured resin is not bonding well with the glass, and then you have an issue. So, and of course that issue especially plays in warmer environments like the Middle East. Then of course the curing is faster and you can get this problem. To counteract the curing, in cases of high temperature, you can add delayer to the resin. That just delays the hardening process. And also, of course, the laminate can be too thin. Of course, it's easily counteracted, this issue, because when the joint is finished, you can just measure the thickness of the laminate. But of course, you should certainly check